Hello everybody, and welcome to our video, which is based on Google, garbage collection. This is our video on YouTube that is going to come up. I hope you all like the video and just comment what all doubts you have on in the end of the video so that we can approach this. Now let's get started. As you see, the main topic here is about garbage collection and the finalized method that we are going to use on the behalf of GC module, which has been given by Java, or it is an inbuilt option in Java, which is used to, decrease the manual garbage collection that we are doing and make it an automatic process which is done by the machine. Uh, in this, as we see in the outline, we are only going to cover these three, and we are not going to touch the garbage collection in .NET as this is going to be a much more complex one. Now let's see what is garbage collection on the outline. It is a memory management technique. As it is said, we decrease the memory that has been given to unneeded reference variables or variables that occupy memory which is not needed and which can be decreased to optimize the memory heap and make the a program more efficient and available for other variables that are going to come in. As you see, and it is also a process of freeing objects, which comes under the same thing that I have explained before. And this no longer referenced by the program. It makes it more easier to see the control flow of the program. Let's go to the next slide. Now let's answer the question why garbage collection is good. Garbage collection is done to reduce the free unreferenced objects like objects which have null values or objects which have memory values which are not needed and which have already been created in the memory space, or they are allocated some memory in the space and which is not needed. We can reduce that. And as you see, all the things are regarding how the heap memory is taken and all. This is why the garbage collection is taken, and we have several disadvantages here. This extra overhead. We don't know where we need variables which are actually in need of the null value. But if it is considered of by the machine as it is done by the machine, it goes into the garbage collection and it directly removes the variable without checking the whole program. And it gives less control over scheduling of CPU time. You can't prioritize your work or the job that has to be done before or after on the which can be done on the manual side. It is done by the machine on this side. So sometimes the job priority might go wrong, and sometimes the things that are going to run in the order will not run in the certain order in which you need them to run to. Now, let us see a garbage collection in Java. These are the three outlines that we can remember to make it more easier for the people. The purpose is to find and delete untraceable objects and free space as much as possible. This is the complete outline of the purpose, which makes it much easier for you to remember as a bullet point and write it down, and you can elaborate after some time in reading it more, in depth. When GC is in control of the JVM, as I said, it is completely in the hands of the machine. We can't override anything. It is done by the machine once activated. And one can request, but there is no guarantee that the GC will get activated or the garbage collection will get activated all the time. There might be some instances where the computer may crash and it might not get activated at all. And if we go to how it is used for discovery of untraceable objects and with the help of algorithms. We are not going to touch the algorithms here, which might be the train algorithm or more algorithms which will come in the later part. We're not going to touch all that slides because they are much more deeper in references and very hard to guess them and understand them. So let us see ways for making objects eligible for collection. We know that we are going to collect objects, but these are the three types of objects that we are going to collect. It's nulling a reference, like having a null value, reassigning a reference variable. It's kind of having same reference variables or something, and isolating a reference. These are the main 3 points at which we are going to eliminate them in the program to make it, less memory consumption and making it more efficient. We can force the garbage collection to happen, or in this case, we are going to initiate the garbage collection by methods available to perform under GC. It's a module, and it is only request and non demands. We can demand it to completely do the GC collection. It happens only when the machine gets activated and it gets the method to process. It is using a runtime class, or mainly sometimes the main method in which we are going to write the finalize method or the GC method where it's going to run. And we are using some standard methods like system.gc, which is standard for most of the garbage collections. But this time we are going to focus more on the finalize method to make it more easier. So as you see, this is a finalization. It is a resource representing a file. A network connection is able to clean itself up properly when a garbage collector decides to free the resource's memory. So if we have a certain variable or a resource that is occupying the memory, and if we want to clean it, it has to happen in a seamless manner. It should not be in such a way that you are going to force the thing to happen and make it more harder for the people to understand that. And below this is the point which I've discussed already, where how the garbage collector detects and how it removes the variables regarding that. Mainly, we have seen the points on which it removes the variables. I think referencing that in the back of the video will make it much more easier for you rather than reading this point on the whole and explaining it to you again and again. It's just going to take much of our time. I think we are going to complete this in almost a 10-minute video at max to make it much more easier for you people to just browse through and for the beginners to just understand what finalize method here is. See, finalize is very different from destructors. Destructors, as we know, are going to destroy the objects on the whole, but in finalize, it's not going to happen in such a way. The object is alive at a point of creation, but it is going to die on the course of garbage collection in the program, where we give life and as well as take it in a certain order. Finalizable objects get promoted to older generations, which increases memory pressure. This can be understood by most of the people who are into the Java, core, but I think we won't be touching it on the deep here. Just make note of this point, which will get used to in the future. All objects referred to directly or indirectly by this object get promoted as well. Forcing the other character to execute a finalize method can significantly hurt performance. This is one of the disadvantages of finalize method. Here, the performance gets reduced because sometimes the variables which are very necessary for the complete program to run are also removed, and in some points it's going to take much more time to remove all the variables, and it goes in a systematic manner. So it takes a lot of your time, and it hurts the performance in such a way that the CPU takes a lot of time to calculate all of these and remove them meticulously. So it takes a lot of time and it hurts the CPU memory power for certain a bit of time until you get to the end of the program and again run. Financial objects may refer to other objects prolonging their lifetime unnecessarily. So yeah, a finalizer objects prolonging their lifetime unnecessarily. We can see some other objects that have not been used or which have been used, and they prolong their lifetime unnecessarily. It means it gives them more, availability throughout the program, even though not needed. So that also is going to, undermine the efficiency of the program and just damage the complete efficiency. So yeah, these are all the points that we have covered already. So I'm not going to touch them again. But if you need, you can just take a screenshot or you can just see them. As you can see, this is the finalization internals. We are not going to touch the starting finalization internals because it's just how the GC character starts. Here we have two queues, which is the freezable queue or the finalization queue. These are the two queues. The finalization queue is in which we keep the objects that are going to be popped, which are not necessary for the memory allocation. We are going to remove them regarding how the objects are placed. We are going to go in orderly manner and remove them in a queue and then again pop them out when they are needed in the heap. This is the heap where we are going to, allocate all the memory required. And these are the queues through which we are going to see how the garbage collection is going to be resolved. So on the whole, these two views, I've already told you how they work. So this is a special time run thread dedicated to calling the finalize method. So if there is a special runtime thread dedicated to calling finalize method, if it goes into the program and it has run before a certain other variables that have been given, it first gets activated and goes back and clears all the things which are on the first, and then returns to the point at where the program has started. So sometimes this is going to hurt the program efficiency, as the important part of the code, if it is below the thread that you have specified, it's going to take a lot of time to come back to the important part of the code and run it. So it's going to increase the time complexity in a way if not used legitimately. See, as I say, it goes to the finalization queue and the pre-reachable queue and it checks whether they are truly garbage or it meticulously checks always. As I said, it's going to take a lot of time and it takes a toll on the CPU power. So if it checks whether it is garbage or not and then removes them. It's not going to just push it on the null value and remove it. It's going to take some time to just process all this. This is the finalization internal, and if you come to the resurrection part, as I said, the finalization first it dies, it lives and dies again. As I said, at the start the variable isn't even declared, so we can consider as it is a dead object. Once it has been declared and has given memory, it is a living variable. And after you initialize the GC or garbage collector or the finalize method, it's going to die again. So that's how the phenomena of resurrection is also known as. So this is the basic syntax which is needed to see. And these are the references which I've used. These two are, one of the classic publications. They are little old, but they are always, best to go back and check for your basic fundamentals. They're going to help you a lot. And these two are the sites that I have used. You can just browse them and just go through what I've picked and kept through. There are also certain parts of the site where you see the algorithms, how the algorithms work, and how the queues, finalization queue, and the preable queue completely work on the inside. For the people who want to go into garbage collection in a deeper perspective and understand them, it's going to be a very better experience for them to go through these websites and notebooks, sorry, textbooks to make it more easier. And then the questions, just spam the comment box with the questions, whatever you have. We'll be, I will be very enthusiastic and ready to answer all your questions once you put them forward in the comment box. And thank you, but we won't be ending it right here because this is going to, just break all that. Let's go to the, code, sample code. This is there in Java object finalize method, which is given under Java T-point. This is a code that I'm going to run in the Java T-point compiler. But the only problem here, I'm going to explain it in a bit. So yeah, as you can see, this is the public class that we are going to create. So the file name is.
Okay, this is going to be the extension of the video of the code that I have set. Here we see the public Java finalize example class 1 that I have all explained. So this is the complete output that I have explained in the video, and thanks for watching.
Content, as this is not completely, you know, so, backend based thing. So if you want to check in the backend, you have to run it on the command prompt. That is going to be an easier task for you. But for just an outline, we're going to run it on net. So if you see the compile and run, yeah, here this is the reference address at which the memory has been created. After the garbage collection, this end of collection has been done. And as I told you, the object dot finalize has not as always is always going to run as it is a part of the GC module. And then we are going to run this statement finalize method call. So this will be the end of the video for now. I hope you understand this and go to garbage collection, as it is one of the fun things to learn and it is very easy. But it is one of the significant things that you ought to learn to make your memory consumption less and make your time complexity decrease in a legitimate way if used in a correct manner. So thanks thanks for listening to me and thank you.